Welcome to Module 7 of Security in a Cloud-Enabled World. In this module, we'll be covering four different aspects, or four different stages of the Customer Recommendations Roadmap. We'll be covering application security, network security, operating system management and middleware security, and fabric and physical security. These are still relevant in the cloud world, but are heavily focused on on-premise and non-cloud aspects, and so we've pulled them together. We will also be discussing threat modeling in this module and how that applies to it, which can be used for a number of different scenarios, so we'll be discussing that as well. So, when we look at application security, and actually before we jump into the meat of it, I wanted to take a moment and call your attention that in the cloud security poster and in the slides here, you'll start to notice that there's a gap under software as a service. And this is where, much like in that blue and gray chart, there was a set of responsibilities that the customer has to take care of that start fading off as you're using SaaS, PaaS, and IaaS instead of private cloud and on down. This is starting to reflect in the roadmap as well, whereas application security, you don't have to patch or update a software as a service application that's done for you by the cloud provider. So you'll start seeing more and more white space on the left-hand side, and that's just something I wanted to call your attention to. So if you do have applications that either your cloud depends on or that are going to be hosted on the cloud, you will want to secure those applications. And there's really two different types. There's applications that you acquire, so whether it's box software that you then install on an IaaS instance or otherwise compiled in something that you don't control the source code of. In that case, you need to apply a set of security considerations throughout the life cycle to make sure that that software starts secure and stays secure throughout the life cycle. And then at the same time, if you are writing code, say for PaaS or you have an application you're hosting on IaaS or private cloud that you own and write the code for, in that case you also need to secure it through the life cycle. The life cycle is a little bit different for an application that you actually develop versus one that you purchase. And so we'll cover both of those. The first is for applications that you acquire. You want it to start secure, and so there's you want to set a set of acquisition and purchasing standards so that when you purchase software and cloud services, for that matter, that you are asking the vendors and or requiring the vendors, depending on your ability to exert influence in the marketplace, to meet security standards, and that you want them to follow SDL, to maintain a good chain of custody on the code that they produce. There's a set of security standards that you should be applying in your acquisition and purchasing to make sure that this is indeed a piece of code that you can trust. And then during the media download and storage, you want to make sure that the software is at a high integrity point, so that as it left the vendor, it is how you install it, and it doesn't get tampered with as it's stored on your network or on an install image or the like. We have seen here and there some attacks on stored installation media. It's not particularly popular at this point in time, but it is something that we have seen exploited, and it's very possible for adversaries to ramp up on that very quickly. And then the last piece is you want to follow the vendor configuration requirements and get those security configuration requirements from them. There is, in most cases, the vendor security configuration recommendations are good. There are some cases where they do actually conflict with Microsoft recommendations, so something to look out for and be aware of. But for the most part, following the vendor security recommendations is the best course. And then the next piece is you want it to stay secure throughout the life cycle of it. And ultimately, this is all about applying security updates. So as the vendor releases those security updates, you have to apply those and get those applied as quickly as possible for the applications that you acquire. And that helps ensure that those security boundaries that are in the design actually stay at a high integrity level. It's like having a known hole in the wall. if you don't actually apply the security updates. And then, of course, end-of-life planning. You don't want to be in a position where at the end of life you have, for example, recently Windows XP or Windows 2003 running and operating on your environment, or an application that can't be updated. You don't want to be in a position where you can't patch it because the vendor simply isn't producing patches because they told you 10 years ago that there will be no more patches after 10 years. In the case of XP or 2003, but the applications as well. You want to make sure that that's included in how you manage your IT and your IT security, is that you incorporate that end-of-life planning and make sure that you're not, you don't have any business dependencies on insecure software or software that can't be secured. So very critical to keep that in mind for the applications you acquire, to start secure, stay secure, and always keep that end of life in the plan. And then for the applications that you actually code and write and have control over, whether it's something that you have full-time employees doing, or whether it's something that that you have contracted out but you still own and control the code for, we do strongly recommend applying the security development lifecycle, or SDL. And ultimately, as Tim was mentioning in the first couple of modules, you want to reduce the number and impact of security issues. There will be mistakes. People are human, and humans write code, and humans make mistakes. It's just a natural thing. And ultimately, by applying and following the software development, the security development lifecycle process, you can reduce the number of security vulnerabilities that you have, as well as the impact of the ones that you do have. And then, because there's a lot of aspects to this security development lifecycle, we did want to spend a little bit of time on threat models, because if there's only one thing that you do in the security development lifecycle, and this is not only for applications, but threat modeling also applies outside of there to infrastructure, which we'll show in a moment, you want to follow the threat modeling, because threat modeling really helps you look at the application as an attacker would look at it. It doesn't make you think like an attacker overall, but it does make you think about how you would attack the application, which helps you increase the security of it. And it's a very good way to walk through that process in a very regular, rigorous way, so that you don't miss some of the obvious and common types of issues. So we'll cover a simplified version of threat modeling on the next couple of slides. And the reason why we like to go through a threat modeling exercise, there's an old saying, there's a saying in the security industry, which is that defenders think in lists, like checklists, and attackers think in graphs. And graphs being, nodes and then the connection points between them. And it's very apropos, because attackers really don't think like we do. When we're putting up a network and we're worried about operational and does it work, and is it going to stay up, and is it reliable? But when an attacker looks at that network, he's seeing, what can I get from here? And he goes through he or she goes through a series of stages and asks, okay, for any given asset like a server or workstation or a system, what is the intrinsic value of here? Does it have data that I'm targeting? Does it have a mission or business value that I want to get access to? And then the attacker would ask, what is my ability to get here? Can I use stolen credentials? Can I exploit network services? Credentials I've already stolen. Can I exploit a listening service? Can I convince the user to do something to let me in? And how can I come back here later? How can I persist so that once I get on here, that I can actually stay on here and come back to it? And do I already have a credential with the admin rights? Can I get there with unpatched software? What credentials can I steal, such as a local admin password hash, to get back here? Is there detection here to find me? Can it be disabled? And this is kind of the thought process that an attacker would go through when they're looking at this. And then, of course, what else does this get me? Can this get me to the next hop? Can this get me to closer to my target or to my target? Am I in the DMZ? Am I in the extranet, or am I in the production environment? Am I in a legacy quarantine zone, or am I in a high value asset zone? What can I get to from this, and what network VLAN, et cetera, can I get on? And of course, what credentials can I steal that I can then use somewhere else? And so that's really how an attacker views the systems we have. And threat modeling helps bring you into that mindset by asking a set of specific questions around that. And so what I'm going to be talking about in the next few slides is a question-based way of doing this, way of doing threat modeling that simplifies it, the traditional method, so that it's easy to apply very quickly to any system, whether it's a cloud-based or on-premise or hybrid solution. So the interesting thing about threat modeling is that it can be applied at several different levels. An application developer really is in control of and cares about components. So things like the web server and the config is separate from the web pages, the database server is separate from the database, and of course the user is there crossing that trust boundary between the internet and the extranet. And then, at an IT pro or infrastructure IT pro level, they really think and care about servers and, of course, the external users. And they may or may not care specifically about the web config or have any need to look at that configuration or have influence over that. It's just to him a web server and a database. So he has a little bit different view of it, and he or she. And an enterprise architect would also have potentially a different view of it, where they would look at things in terms of a complete set of systems and how they interact. And as we expand the enterprise architect out a little bit, you can see here that there's many different components in it in a very large architecture. This is a diagram of an example of a retail system that has internal ERP, sales and inventory, point of sales, card readers, issuing banks, payment processors, and the like. And so you can see that the threat modeling, which applies to these diagrams, can be applied at any of those levels. And when we look at applying the threat modeling, there's really one very important place that we want to focus and prioritize, which is anything that touches a trust boundary. And so if you remember from the previous ones, there was that trust boundary between the internet and the extranet. And really anything that touches that, which is the data flow that crosses it between our user and our web server, and the web server on one side and the user on the other side, both of those touch that trust boundary. All of those things are the most important parts of the system to look at, because they're essentially guarding that trust boundary and ensuring that nothing can cross it, because they cross it, they're a potential avenue for an attacker to cross it. And so it's very important to apply the threat modeling to that piece at a minimum, and ideally you want to apply it to the whole system, and we'll have the questions up in the next slide. But the minimum piece that we want to focus on is anything that touches that trust boundary. And this really goes back to those containment zones that we talked about in the previous module, where when we talk about allowing an exception, hey, such and such wants a port open from the DMZ into production. Well, let's go ahead and ask them let's go ahead and do a threat model on the interaction that they want that port open for, and then we can have a much better understanding of the risk about whether or not we do or don't allow that connection. And so it's very important to apply the due diligence and that rigor whenever you're crossing that trust boundary. And so you look at those entities there. And you'll notice there's a couple different types of entities, and you ask different questions for each of them. The process, which is that blue circle there for the web server. The external entity, which is a user, in this case, is the green square, and then of course the data stores are the ones that look like the little the database cylinders, and then the data flows that go between them. And so, depending on what type of object it is, you're going to ask a different set of questions. For a process, you would ask, how do you authenticate it? Is there denial of service protection? Who can access or modify the binaries? What identity does the process run as? For the data flows, those lines between them, how important is this data? Is it encrypted in transit? And then for the data stores, how important is the data, who can access or modify it, and do you encrypt the data? And then for those external entities, there's really one main question, which is how do you authenticate the entity, rather. And then there's another set of questions around the infrastructure side of things. So, if you're talking about an operating system as the process, what management tools are installed, are the servers virtualized, how are they backed up? And that helps you understand some of the risks there. And then the Active Directory and identities, for any machine or for any user, what domain are they joined to, and it helps understand the context of it. And then from an operations standpoint, you'd also ask about how many admin accounts do you have on a particular server dedicated, are you using dedicated admin accounts and workstations, or are they, standard user accounts and or standard user workstations? And so these are the questions that you can ask that will help you understand that system and think about it from the opportunities that an attacker could use to attack it. So when we look at the network layer, which again applies to PaaS, IaaS, and private cloud, much like the application layer does, you really want to think about it in terms of you don't want to just rely on that network security, because that network-centric thinking won't get you to the point where you have an understanding of what's really going over the wire like a threat model would. And whenever you look at the network security piece, it's got to align to your overall security strategy and your containment strategy, and it's got to support that. And it's also got to align well with your identity strategy, because if you try to put firewalls between nodes in a particular domain, like between Active Directory domain controllers, or between computers and domain controllers in the same domain, you're going to end up creating a lot more operational issues and very little net gain in security, if any. So it's really important to align that network strategy with your security strategy, your containment strategy, and your identity. And so that's very critical there, and you want to spend time thinking about that, and not just applying classic firewall thinking. Optimizing with cloud capabilities. So the nice thing about cloud is it brings in this essentially software-defined networking, which opens up a new world of being able to turn things off, turn things on, have an extra copy of things, and it really allows you to do some new things that were not possible back when you had to go and plug in the laptop to the serial port of the router in the closet to make any change. Now you can do it through software, you can do it through PowerShell and automation. So there's a lot of opportunities to look at things different there and embrace some of those cloud capabilities, which also include the ability to stand up an appliance very quickly in Azure through different appliances from the marketplace and the like. And so that's something that's very, very important to look at, because that's an opportunity to increase your security using cloud technology. And of course, managing and monitoring network security is very, very critical, because when I look at networking security, I think of it much like looking at trucks driving on the road, because it's carrying stuff to and from, and it's the pathways that enable those things to work. And when you think about detecting something that's going on that's unusual on the roadways, it's a lot easier to detect that a truck is driving in a pattern that it's never done before, assuming you can track all the patterns like you would on a network, than it is to inspect every single package and every single box in the truck as it goes by. And computer networks are very much very similar to that, in that the network traffic flow patterns can show an anomaly very, very more obviously than attempting to get into the packet. With the pervasiveness of encryption, with the adversary advanced usage of encryption, and with all the different applications and all the different protocols that they're using, it's very, very difficult to understand the content of what's going on from a network layer. But it's a lot easier to understand the traffic flow patterns, and what an adversary is going to do on the network is going to be very different than what a legitimate user is going to do. So it's something that you should look at from that perspective for identifying things and use it for what it's strong at. And then as we move to just the IaaS and private cloud layer, you have to run and manage a full operating system stack. For PaaS, you're pretty well done. Network and application plus the first four, you're good. But as you move into the operating system and middleware piece, in an IaaS or private cloud, you do have to secure that OS, that middleware, and of course the apps installed on it in the IaaS and private cloud space. And there's a lot of complexity and a lot of things to secure for an operating system, and we've listed a number of them here, and including the management tools too. Because if I have a management tool agent that's installed on a servers, for configuration management, operations management, security tool, generally I have control of that server. Because as a configuration management tool, I can install software, run arbitrary tools and scripts. Same thing with an operations management, and usually the security tools have administrative access to the computers they manage. And so it's very important to secure that whole stack of it and all the security dependencies, including those management tools. And there is quite a bit of work to doing that and to getting it secure. Some of which we covered in the client section, but on the server side, there's a little bit more in the management tools as well. So we're not going to get into that in too much depth, but just understand that in those scenarios, in on-prem, private cloud, and IaaS, you do have to secure those at a level that will stand up to the modern attackers. And then as you get into private cloud, and quite frankly, we couldn't put them all in a little narrow column to the right, there's, this is only applying to private cloud and on-premise. If you're running that fabric, you have a lot of the same things over again at that layer, such as the fabric and data center identities, but you also have the physical network. You have server and device firmware where the attackers can embed themselves and attack. You have the adversaries able to attack the storage, the firmware, the stored files, etc. The physical operating system and middleware that's installed there. So again, on roadmap 7 all over again in AD there. And physical security of the data center, the fabric management, the virtualization solution. And so there's a significant amount of security that gets added if you do a private cloud. And it's something to consider as you're looking at your solutions. There may be valid reasons to do the private cloud, and it may be something that that is necessary for your business, but you just recognize that it is a lot higher burden, a lot higher bar to meet to keep that secure. And so the key takeaways here for these last 4 pieces of the roadmap is apply that software security throughout that life cycle for both the applications that you buy, the life cycle of that, as well as the in-house applications that you develop or you have developed for you. And the security does really need to focus on all layers, not just the network. It's a very critical mindset change that we absolutely have to look at all of these layers when we're looking at security. Securing the operating system layer is very complex. It is very challenging. It is very difficult. It's something that my cybersecurity team, does a lot of work on, and it is a very challenging space. And it is something that's very, very hard to get 100% right or close to it. And so, just kind of keep that in mind. And private cloud does bring you more control, but it does bring more responsibility as well from a security standpoint. And that concludes Module 7. Thank you.